Hello, this is Advanced Math, Chapter 12 on Vectors, Homework Quiz D, Recap. If you haven't taken Homework Quiz D yet, or if you have and you want to take another shot at it, take a look at this recap video where we talk about a question that's very similar, but not the same. So I've got the statement of the question, statement of the problem here. We've given that we have a point A at these coordinates. This is a three-dimensional point x, y, and z, and a vector u with these components, x, y, and z. Find the equation of a plane that's perpendicular to vector u and that passes through point A. So when we come up with this equation for a plane, the coordinates of point A will satisfy the equation and the plane will be perpendicular to the vector u. So in the classwork, we went through a fairly straightforward process for doing something like this. The relationship between a vector and a plane that's perpendicular to the vector is that the coefficients of the plane equation will be the same as the components of the vector. So let's try that. We can write a preliminary equation for the plane in a standard form using these components. So the standard form of a plane equation, ax plus by plus cz equals d. And for the a, b, and c, we'll use the components, x, y, and z components of the vector u. So I'll write that again. 1x plus 4y plus 5z equals d. Don't know what d is yet, but you can see that the coefficients match the components of vector u, which is the perpendicular vector. So the next step is to say, well, we know that this point A at 2, 3, 1 will work in this equation. So if we substitute the coordinates, x, y, and z coordinates for point A into this equation, we'll be able to evaluate the left-hand side and determine what the value of d is. So let's do that. Substituting the coordinates of point A, we have 2 plus 4 times 3 plus 5 times 1 equals d. And this evaluates to 2 plus 12 plus 5, which is d, or 19 equals d. So this is the value of d. We can go back up to this step and substitute this value for d and rewrite our equation. Thus, x plus 4y plus 5z equals 19. And that finally is our equation for the plane. I think that's it.